Newton says gravity is a physical force pulling on that satellite, but Einstein says, gravity isn't a physical force at all. It's just an artifact of Earth curving the space-time around it, and that satellite, it's moving straight through that curved space-time. But my question is why? Why did Einstein and humanity conclude that? I mean, it's cool to repeat quotes like matter tells space-time how to curve and space-time tells matter how to move. But science is not about understanding facts. It's about sharpening our thinking. We have theories for why things fall down for thousands of years. For example, Aristotle believed everything naturally tends to move towards the center of the universe, which is obviously the Earth. Meanwhile, Brahmagupta in ancient India used the term guruta, a Sanskrit word meaning attraction due to heaviness. That's pretty cool if you ask me. Copernicus helped replace the Earth with the sun at the center. Galileo made breakthroughs in inertia and motion, and Kepler uncovered stunningly accurate features of planetary orbits. For example, that they were ellipses, not perfect circles. In 1665, one of the deadliest plagues swept through London, killing up to 100,000 people, nearly 15 to 20% of the city's population. One of those students was a young man named Isaac Newton. For the next couple of years, Newton was pretty much stuck at home, but free from exams and lectures, he could pursue whatever he wanted. And here's that book, Principia. Okay, actually, it's a copy of it translated in English. But if we go to volume 3 here, you can see that he proposes that the planets experience a force towards the sun that drops as 1r2. I find it fascinating because this is the copy of the original text that for the very first time wrote it down in the history. Oh my God, that's amazing, right? It didn't just explain orbits or how things fell, but also the tides predicted the return of Halley's Comet, and a couple of centuries later even helped discover a brand new planet, Neptune, purely from the math. And Einstein says, it's kind of like solving a puzzle one piece at a time, only to eventually realize you've actually learned backend coding like on boot.dv, the sponsor of this video. If you go to its homepage, boot.dv claims to be the most captivating, most addictive way to learn backend programming. And what I found was, unlike traditional courses, there was no long lectures or theories. You just read a short instruction and you start coding immediately. And of course, if you get stuck, there's this AI chatbot called Boots who will nudge you in the right direction. But wait a second, why learn backend development in the first place, you ask? Well, because you can make serious money. Top backend developers earn over $150K annually. But there was a problem. Special relativity and Newton's law of gravity were incompatible. But why? Well, Einstein says according to special relativity, no information can travel faster than light. When you're in an airplane and that airplane is taking off, it accelerates forward, you feel pressed backwards, right? Similarly, when you're in a car taking a turn, you accelerate inwards, but you get thrown outwards. I remember skydiving a few years ago in Switzerland. It was honestly a pretty amazing experience. But when I jumped, the moment I jumped from the plane, I felt nothing. No jolts. Totally weightless for a few seconds until the air started pushing. While I'm falling, if I were to drop an apple, that apple would fall along with me because gravity accelerates every single thing at the same rate regardless of its mass. And fun fact, this is the reason why F1 drivers have enormous neck muscles. They need it to withstand huge turning forces. Falling things also stretch and squeeze. It's just that for small things, we don't notice it. But if there was something huge like an asteroid hurling towards the Earth, it would stretch significantly. Even the Earth and Moon fall towards each other and they're pretty big. So they too significantly stretch and squeeze, and on Earth this effect is what gives rise to tides. If a small rock is at rest in space, it's still moving in time, so its graph is straight and vertical. We call this the rock's world line. If the rock's moving at a constant velocity, it's still straight but tilted. Imagine two people walking north from the equator along the lines of longitude. They start off parallel, and they are walking as straight as possible. No turning, no curving, and yet they slowly move closer together. Now, if the surface was like a saddle, then the straight parallel paths could also drift apart. If the underlying spacetime itself is curved, then, like on a saddle, parallel geodesics can diverge. This is how we can explain the asteroid stretching. So look, in curved spacetime Earth's surface must be in a constant outward acceleration just to maintain its shape, otherwise it would collapse inwards. We just rediscovered the step-by-step thinking process that planted the seeds for general relativity. But this is just the tip of the iceberg. I mean, Einstein got stuck again. So let me know if you want to dig deeper. There is so much more to rediscover over here. Stay tuned.